Here's another example of solving a system of three equations with three variables. Again, this is number 14 in section 7.2 of your book. So here's my system. Again, you can eliminate the x's or the y's or the z's. The choice is yours. It makes absolutely no difference. I'm going to pick the y's because I think they're going to provide me the least amount of resistance. So what I'm going to do is from the top and the bottom, or excuse me, the top and the middle, I notice the y's are just going to cancel. So that's nice. I like to do as little work as I possibly have to. So 2x and negative x is 1x. Y minus y is 0, z plus z is 2z, and then 9 plus 1 is 10. I notice here that the same thing would happen with the top and the bottom. You could also use the middle and the bottom. It does not matter, but they just have to be two different equations than the previous. So I am going to, from these two, I'm going to add these two together now. So 2x and 3x, that is 5x. Y minus y is 0, z plus z is 2z, and then 9 plus 9 is 18. Great. Again, now I've eliminated one of the variables. I have the same situation as we solved in section 7.1. I can eliminate the x's or the z's. It doesn't matter. So what I'm going to do here is I'm going to multiply this by -5. I'm going to eliminate the x's. If you wanted to eliminate the z's, multiply by -1. It's not going to matter either way. So -5 times x. Negative 5x, negative 5 times 2 is negative 10z, and negative 5 times 10 is negative 50. The bottom equation I have not touched in this particular problem, so I'm going to rewrite it. And so now negative 5 and 5, that's 0. Negative 10 and 2 is 8z, and negative 50 and 18 is negative 32, it looks like. So now I'm going to divide both sides by 8. And I end up with my z is -4. Fantastic. Now the rest of the problem is just tracking back and figuring out what your values are. So I'm going to take the z is -4. I'm going to go to this top equation here. So I have x plus 2 times -4 is equal to 10. And so that is going to be x minus 8 is equal to 10. And then when I add the 8 to both sides, I get x is equal to 18. I made a mistake, but that's okay. I'm not going to re-record the video. It's just a little bit of a sign error. Down here, negative 10 plus 2 is 8. You're probably screaming at me into your computer as you're watching. So negative 10 plus 2 is negative 8. So when I divide it here, that should be a positive 4. So my apologies, no big deal. Okay, the arithmetic will work itself out. So let me now redo this. So I'm going to take the positive 4 now, and I'm going to put it back up here. So I've got x plus 2 times 4 is equal to 10. And then x plus 8 equals 10. And when I subtract the 8 from both sides, I get that x is equal to 2. Finally, I'm just going to use this bottom equation. So 3 times my 2 minus y plus z, which is 4, is equal to 9. 3 times 2 is 6. 6 and 4 is 10. When I subtract the 10, I get negative y is equal to -1. And when I divide, I get y equals 1. And there is my solution. So always write it as an ordered triple. So my x value was 2. My y value was 1. My z value is 4. I put some squigglies around it because it's a set. And there you go. We've solved the system.